All right, video assessment for Jada Clark, chapter 18, problem 52. So first we're going to do is find the equivalent resistance for this whole circuit. And by remembering our equivalent resistance rules over resistors in series and resistors in parallel. So first we're going to start with this little branch right here and do two resistors in parallel. So we know 1 over 4 plus 1 over 8 is going to equal 1 over 0.375. So, and that equals 1 over REQ. So now we have to take the reciprocal of this to find actual REQ. So REQ is going to equal 1 over 0.375, which equals 2.67. Okay. Next, we can do these two in series and these two in series. So just by that, you're just going to add them together. So R2 plus R4 is going to be 2 ohms plus 1 ohm, which equals 3. And then for R3 and then RB now is going to be 3.3 plus 2.7 equals 6. Now these two are in parallel, so we're going to add those by putting 1 over those. So we're going to do 1 over 3 plus 1 over 6, which is going to equal 1 over 0.5. And then remember, you got to take the reciprocal, so REQ is going to equal 1 over 0.5, which equals 2 ohms. And so now this whole thing, this whole parallel section equals 2 ohms like that. And then these two equal 6, 3. And now this whole thing is just in series with resistor 1, so we can just add them together. So 2 ohms plus 1 ohm is going to equal REQ. And REQ is going to equal 3 ohms. And that is the answer to problem A. Next, we're going to find the current through this 1 ohm resistor, and we know that an 18 volt EMF is connected because that's given right here, and then we found the resistance, equivalent resistance, and so now we're going to use Ohm's law to find current, and now we know current equals voltage over resistance. So V over R, which is going to equal 18 volts over 3 ohms, and so I is going to equal 6 amps. So now we know the answer to problem B. All right, last but not least, we just redrew the circuit with all of our answers here. So this is 2.7, 2, 6, 3. All right, now we have to find the current through the 8 ohm resistor. And then, so to do that, we have to do our first step. Our first step is to find the voltage drop across this lower branch right here. So we'll just call it VP over this parallel section and then this 3.3 section right there. So because of Ohm's law, we know voltage equals current times resistance. So we know I, which is 6 amps because we just found that. And then we have to do it over RD, which is right here. So as I was saying, we have to do current times resistance, and we have to use the resistance over the whole parallel part. So RP, and that's going to equal 6 times 2, which equals 12 volts over this lower section. Next, we have to find current through this one right here, which will help us find current through these two put together because we know current is equivalent through resistors in series. So I is going to equal VP divided by RD, which is that right there. 12 divided by 6, I is going to equal 2 amps right there. And so then we have to find our voltage drop through these two right here. And because we know our voltage drop is going to be the same between these two because they're in parallel. So next we're going to do voltage equals I times RB, which is going to equal 2 times 2.7, which is going to equal 5.4 volts for RB. And then lastly, we have to find our current through R6. So now we know our voltage drop, V divided by R, is going to equal 5.4 divided by 8, because that's what we're given. And that's going to equal 0.675 amps. And that is our answer right there.